Assalamualaikum and hi everyone. Today we continue with new chapter 4, linear programming. For this chapter, you need to use graph paper. For this chapter, we have two subtopics, 4.1 system of linear inequalities and 4.2 problem interpretation, formulation and solving. But for this video, we just focus on system of linear inequalities. For introduction, we need to know what is linear inequalities first. Linear inequalities is a linear function that use inequalities sign, which is more than or equal to, less than, and less than or equal to. Then we have system of linear inequalities. System of linear inequalities is formed by two or more linear inequalities of the same variables. For example, we have 4 linear inequalities. So this one we call it as system of linear inequalities. Then next, solid line and broken line. For example, we have two diagrams here. The first one, y greater than x minus 3. Since the function use sign greater and doesn't have equal sign, so we use dot line. And dot line we call it as broken line. Next diagram, we have y greater than or equal to x minus 3. Since it has equal sign, so we use straight line. And this one we call it as solid line. And last is feasible region, where we denote it as R. Example, we have two region here. The first one we call it as closed region. And the second one is open region. To 4.1 system of linear inequalities. First, represent the system of linear inequalities graphically. We look at example number 1. A. We need to represent this system of linear inequalities graphically. So means we need to sketch the graph and find the feasible region. Okay, now we look first equation. We have y less than x plus 1. To sketch the graph, we need to find x and y intercept. When x equals to 0, then we get y equals to 1. And when y equals to 0, so we get x equals to negative 1. In next equation, we have 2x plus 3y less than or equals to 6. Okay, before we find the intercept, we need to arrange only y on the left side. So we get 3y less than or equals to 6 minus 2x. Only positive y on the left side. Okay, then we find x and y intercept. When x equals to 0, we get y equals to 2. When y equals to 0, then we get x equals to 3. We take out our graph paper. We sketch y and x axis. For first function, our intercept is negative 1 and 1. So we sketch straight line from negative 1 to 1. And we put dot line since y less than only. Doesn't have equal sign. That's why we put broken line. And we label this line as y equals to x plus 1. On the graph paper, need to put equal sign. Next function, we have intercept x equals to 3 and y equals to 2. So we sketch graph. We use solid line since y less than equal. Since have equal sign, so we use solid line. Then we label the graph 3y equals to 6 minus 2x. On the graph paper, we put y equal sign only. Okay, next we have x greater than or equals to 0. Means we have x equals to 0 on y axis. So straight line on y axis. Then we have y greater than or equals to 0. Means y equals to 0 on x axis. So straight line on x axis. Okay, next, we determine the feasible region by look at the inequality signs. So first line, y equals to x plus 1. Okay, we have y less than. So below the line y equals to x plus 1. Next function, we have y less than or equal to. Okay, less than, so below the line. For x equals to 0 is greater than. So the area on the right y exists. And for y greater than or equals to 0 means area above the line x exists. Then we can conclude the feasible region is here. We look second example, B, first equation. We have 4 minus y greater than x. So first step, we need to arrange positive y on the left side only. Then we get y less than 4 minus x. Okay, next we find x and y intercept. When x equals to 0, we get y 4. And when y equals to 0, we get x 4. Next equation, we have y minus 3x plus 2 greater than or equals to 0. We arrange first. Then we get y greater than or equals to 3x minus 2. Next, we find the intercept. When x equals to 0, we get y negative 2. And when y equals to 0, we get x 2 over 3. Okay. Next, we take out our graph paper. We put x and y as is. Okay, then we look at the first equation. Our intercept is 4, 4. So we put 4, 4. Then we sketch broken line at 4, 4. Since y less than only. So we use broken line. Then we label as y equal to 4 minus x. We use sign equal. Okay, next equation, we have intercept 2 over 3 and negative 2. So we sketch negative 2 for y and x 2 over 3. Then we use solid line. Since y greater equal, we have equal sign. So we use solid line. Then we label the line y equals to 3x minus 2. Okay, next we have 0 until 3 for y. So we sketch straight line at x axis, y equals to 0, and straight line at y equals to 3. Okay, and next function, we have x greater than 0, x greater than 0 on y axis. Okay, since x greater only doesn't have equal signs, so we need to put broken line. Okay, and next we find or we determine the feasible region. Okay, first line is y less than. Y less than means below the line. So here, equation 2, y greater than. So means above the line. And we have between 0 until 3. And last, we have x greater than 0. So we can see here, our feasible region is here. And last question, C. We have x greater than or equals to y. So we arrange y on the left side. So y less than or equals to x. Then we find the intercept. When x equals to 0, y 0. Since both are 0, so we need to find other point. So we let x equals to 1 and then we get y so equals to 1. Then we have second equation, x plus y less than or equals to 6. Then we arrange y less than or equals to 6 minus x. Then we find the intercept. We get x equals to 0, y get 6. And when y equals to 0, we get x equals to 6. Then we sketch the graph. We put x and y as is. And first line, we have intercept 0, 0, 1, 1. So we put 0, 0, 1, 1. Since y same as x, so make sure 1, 1, 2, 2, 3, 3, 4, 4 and so on. Value for y same as x. And since y is less than equal, so we put solid line. And we label the line y equals to x. Next equation, we have intercept 6, 6. So we put line at 6, 6. And this one, y less than equal. So we also use solid line. Then we label the line y equals to 6 minus x. Next, we have x greater than or equals to 0. So means on y axis, we have x equals to 0. And last, we have y greater than 0. So on x axis, we put y equals to 0. Since we have greater only, so we use broken line. Then we determine the region. First line, we have y less than equal. So below the line. Okay, next. Second equation, we have y less than equal. So below the line. And we have x greater than or equals to 0. So on the right side of y axis. And y greater than 0. So above x axis. Then we can see here the feasible region is here.